All right, good morning, algebra. So as I said, I would put out a little video for today just to explain like what you're doing. It's just going to be a continuation of what we did yesterday, but so many people were not in class yesterday that I thought it was best that I put out this video. What I'm looking at right here is the notes we did in class yesterday. If you missed them, they will be in Schoology in the week 12, 11-19 folder, or Thursday 11-19 folder. And we did not do the last two problems on the notes, so I'm going to do them now. If you are watching this video to figure out how to do the DeltaMath activity, there will be a link in this video description that will take you to the right timestamp. So let's get into these last two problems on the notes, and then I will explain what you're doing for today's assignment, and also if you needed help on today's DeltaMath activity, that will be towards the end of the video. But again, check the link in the description. That'll take you to the right timestamp. All right, the last two problems on the notes from yesterday. We were doing our linear equation word problems. I have Miss Smith takes a pie out of the oven. The temperature of the pie is 320 degrees. If it cools at a rate of 8 degrees per minute, write an equation that represents the temperature of the pie after it is removed from the oven. So I want to identify my slope, which is what is going to be constantly changing, and my y-intercept, or the initial whatever we're measuring. In this case, we were measuring the temperature. And the temperature of the pie is 320 when she takes it out of the oven. So when she takes it out of the oven, that's not going to be changing at all. It's going to be cooling at this rate, but that 320, that's the initial temperature of the pie. So my y-intercept here is going to be 320. And that is temperature at start. And my slope here would be this 8 degrees. However, this pie is not getting hotter. It is cooling. So if it is cooling, I'm not going to be adding temperature to it. I'm not going to be adding 8 degrees every minute. I'm going to be subtracting 8 degrees every minute. So my m here is actually going to be -8. And that would be degrees lost per minute. So when I want to write my function, I have to put it in the form y equals mx plus b. So I got y equals, and I said m was -8, so -8x plus b, so plus 320. And it wants us to find the temperature of the pie after 30 minutes. So to find the temperature of the pie after 30 minutes, I'm going to do -8 times 30. I'm plugging in 30 for x. Equals, or not equals, plus 320. So -8 times 30 is going to give me -240 plus 320. And -240 plus 320 is 80. So after 30 minutes, that pie is going to be 80 degrees. All right, and the last problem on yesterday's notes. An aircraft is flying at an altitude of 10,000 feet. The pilot puts the aircraft in a steady dive of 50 feet per second. Write an equation that represents the altitude of the aircraft. So let's see. The aircraft is flying at an altitude of 10,000 feet. And then the pilot puts it in a steady dive of 50 feet per second. So that per second tells me that is going to be my rate of change. That is going to be changing. So my slope, my rate of change, because remember slope is the same as rate of change, is going to be that 50. However, if we read the problem carefully, it says he puts it in a steady dive, not a steady ascent. So a steady dive means he's going down. Therefore, he is losing 50 feet per second. He's going down 50 feet per second. So the meaning in context is feet dove. I guess that would be the proper word, feet dove per second. I don't know if that's the right grammar, but I'll just say lost. Excuse me. Then our y-intercept, or like the initial amount, would be the other number in the problem. So there are only two numbers in this problem. So we know one of them is going to be the 50. The other one's going to be the 10,000. If you don't know which one is which, guess. You got a 50-50 shot of getting it right. But our y-intercept is going to be our initial altitude, which is 10,000. So that would be, I guess, the cruising altitude is what they call it, I believe. And then our function, I want to write this in the form y equals mx plus b. So y equals, my m here is negative 50, x plus b, which is 10,000. Negative 50x plus 10,000. And then it asks us to find the altitude of the aircraft after a minute. And remember, this is diving at 50 feet per second. So we need to think about how many seconds are in a minute. Hopefully, you know that there are 60 seconds in a minute. So I'm not plugging in 1 for x. I'm plugging in 60. So I have negative 50 times 60 plus 10,000. All right. So I'm doing negative 50 times 60 in my calculator right now, and I got negative 3,000 plus 10,000. When I add these two together, I'm going to get 7,000 feet as my answer. So those were the last two problems on today's notes. If you missed the rest of today's notes, yesterday's notes, they are in Schoology in the Thursday 11/19 folder. Now I want to look at today's activity because it's going to be basically the same thing, but there's a little bit different stuff. So let's look at it. This one, 3.2.1 Slope-Intercept form word problems practice. So you're basically doing the same thing that we did in the notes. So yeah, you're making a function. Well, I would probably identify your slope or your m and your b first before making your function, and then ask you to evaluate the cost of printing 143 pages in this situation, or whatever. So you're plugging in 143 for x once you make your function. But then it gives you an extra problem with this problem. So it says, Gustav Gregarius paid 483 pieces of gold to have his book printed. How many pages were in his book? So in this one, you're kind of doing the opposite thing. You're using the same function you came up with. Using that function, and let's say, let me look at it. It looks like, you know what, I'll give you guys the function on this one. So the function should be p of x equals 2x plus 45. So you will have to fill in these blanks here and then plug in 143 to solve for y there. But in this bonus problem it gives us, it says he pays 483 pieces of gold. So we're not plugging that in for X because X was the pages. The gold was the Y, or the P of X in this case. So we're doing 483 equals 2X plus 45. And then you would solve for X in this case instead of Y. And that would tell you how many pages he had printed. Let's see. Number 2, it says if his profit follows the model, how much profit will he make after 5 years? So it also says explain your answer. You don't need to do that. I don't care about that. Oh, why did I do that? Yeah, and there's no like bonus problem with that one. Okay, for number 3 here, 940 on each marquee. Fixed costs of doing business are $5,300. Then it wants you to write an equation. But then the problem, or the question it asks, is how many does he need to sell to make a profit of $8,800? So in this case, you are once again not plugging that 8,800 in for X, you're plugging it in for Y once you write your equation. Let me see, are there others where you need to plug it in for Y? Yeah, so it looks like a lot of these you're going to be plugging it in for Y. Wait. Ooh. Hold on. Wait a second. How many shirts would they need to break even? I forget how to do this one. Ico Shirt Check makes a profit of $450 on each t-shirt it sells. Their fixed costs of doing business are $900. Oh, okay. So they make a profit of $450. Wait. Write an equation. Why doesn't this make sense to me all of a sudden? Because it says how many they need to sell to make a $200 profit, but it seems to me like they're already over $200. Oh, okay. So they're fixed costs of doing business. So that means they're paying $900. So in that case, they're losing the $900. So your equation here would be well, I have to start with Y. So Y equals 450X, because that's how much you're making on each t-shirt, minus 900. And to make a $200 profit, you are going to want to plug in 200 for Y, not X, because X is the number of shirts. Y is the profit. And to break even, that means that Y equals 0. So Y equals 0 on that one. Goodness, what is this one? They charge $275 to cater an event. In addition, Fanny charges $35 per pound of frog fritters fried. The Clarence Crock family was charged. Oh, okay. This one isn't too bad. It's just like, you know, you have your initial cost, the cost per event, and then it's saying this other family was charged this much, so you would plug that in for y once you write your equation. Okay, that one isn't bad. So yeah, on this one, they charge $20 per sign plus $2 per letter. So if you're making one sign, that 20 is only being charged to you once. So that would be your B here. This 2 would be your M, and you would use that to write your equation. Then it says, what would it cost you to have a sign made with the message, you can tune a piano, but you can't tune a fish? Meaning you have to count how many letters are in that phrase. You'd have to count how many letters are there, and then you're going to plug that in for X. And then here it says Alphonse paid $72 for his sign. So you're going to figure out what your sign costs. And then this is an entirely different problem. It's just using the same equation here that you wrote using this 20 and this 2. And you're plugging 72 in for y to solve. How many letters Alphonse had in his sign? Oh goodness, this one looks not fun. Okay, so the photographer for a wedding. Oh, no, this one isn't too bad. It's kind of the same thing. You're writing your equation with these two numbers, the 750 and the 450. You plug in 75 for X to figure out the charge for 75 pictures. You plug in 3094.5 for Y to figure out the pictures Phyllis bought. And that would be what you would do here. Okay, so that explains today's assignment, hopefully. If you weren't already, I recommend just watching this video at the same time you're working on the assignment, so that way you can pause it and listen to exactly what I'm telling you to do. So it's where I said, oh, in this one you want to plug it in for Y. Just pause the video and be like, okay, plugging it in for Y, and then hit play again to see what the next step is. All right. So that's all of today's assignment and yesterday's DeltaMath activity, if you missed it. Let's get into it. I'm just going to go over, this was also part of what we did yesterday. So we did determining the equation of a line just by looking at it. And I know these lines are all going to be in the form y equals mx plus b. I know that m is my slope, and the b is my y-intercept. So every single equation I'm going to be writing, I'm going to keep the x and the y, but the m and the b, I'm just going to replace them with numbers. We're not going to do number 5, but we'll do number 6. So number 6, the first thing I can identify is my y-intercept. So on my y-axis, it crosses the y-axis right here at 2, meaning that my y-intercept here is going to be b. So I'm going to have y equals mx plus 2, because 2 was my y-intercept. Now, I need to replace that m with a number, and I am going to find another point that I know is on this line. And looks like that point, 2, 3 is on the line. So now I have 2 points that I've chosen. I've chosen my y-intercept, and I've chosen this 2, 3. So to determine the equation of this line, I have to do m, my slope, is always going to equal rise over run. So to get from this first point, this 0, 2, to the second point, 2, 3, I'm rising 1. So I go up 1, and I run to the right 2. So my rise here was +1. My run here was +2, meaning my m is 1/2. So my equation for this line is y equals 1/2 x plus 2. And I'll do these last two examples together as well. All right, number 7 here. Let's see. I know it's going to be in the form y equals mx plus b. And I'm going to identify my y-intercept, which is 4 on this problem. Remember, my y-intercept is where it crosses the y-axis, the vertical axis. So I know I'm going to have y equals mx plus 4. Then I need to determine what my slope is, my m. So m is always going to be rise over run. So I'm going to pick a point that I know is on this line. So I think that one works. What is that, -1, 1? So to get from my y-intercept to that point, I'm going to be doing my rise over my run. So my rise here is 1, 2, 3, but I went down to get to that point. So if I go down, my rise is negative. So I had a rise of -3. And my run, I'm going over 1. But I went to the left 1. If we go to the left, it's negative. If we go to the right, it's positive. So we went to the left 1, so that means -1. My rise is -3. My run is -1. A -3 over -1, that just simplifies to, well, a negative divided by a negative is a positive, and then 3 over 1 is just 3. So that is just 3. Meaning the equation of this line on number 7 is y equals 3x plus 4. And our last example here, number 8. So my y-intercept here is right there at 0. So I'm going to have y equals mx plus 0. And now I need to determine my slope. So let's see. It looks like it definitely goes to that point right there. So I want rise over run. So to get from my y-intercept to that other point, I'm going to be going, my rise is, I should probably write that. So m equals rise over run. So my rise, I went down 1. So I had a rise of -1. And my run is 1, 2, 3 to the right. So since it's going to the right, it is +3. So my rise here was -1. My run was 3. So -1 over 3, can't simplify that fraction. So that would be my m. So y equals -1/3 x plus 0. Don't really need to say plus 0 because, it's redundant. So this would be my equation for number 8. Y equals -1/3 x. So this is what you guys are doing on the DeltaMath activity. It's only 7 questions. You just have to do this. So please log into DeltaMath.com and do that activity. It should not be too bad. And please make sure that you show up in class. We had a lot of people missing yesterday. It was not fun. Anyways, I will see you guys on Monday. Have a nice rest of your day.